Hi, welcome to my platform, either the Facebook page or the YouTube channel for Sensor Academy. If it is the first time on this particular platform, kindly leave a comment, share the video, and also if it's the first time on this particular YouTube channel, kindly hit on the subscribe button and turn on the notification bell in order to get notified when next I post any video. In today's tutorial, we're going to consider 2023 GCE exam, but by placing our focus in science and particularly chemistry, which is categorically science paper 2. We're going to focus on a question that comes from bonding and also some of the relatable understandings on the periodic table. So this was on question 4 from section B, thereby being called B4. Figure 4.1 shows an electronic structure for element Q. An electronic structure is a diagram that shows the arrangement of electrons in the shells of an atom or an element, while an electronic configuration is a ratio that shows the numbers of electrons in each and every shell of an element. Considering the diagram that we have, so long as you've got a diagram, you can come up with an electronic configuration where you can start with the smallest shell and count the number of electrons or crosses present up to the biggest shell, which is actually the last shell. So for instance, here this is the first shell, this is the second, then this is the third. So in the first shell, automatically the standard number of electrons is always 2. So if this is element Q, we're going to say the first shell has 2, comma. Then the second shell, it has got 2, 4, 6, 8. So we're going to say 8, comma. The last shell has got 2, 4, 6, 7. So which means this is 2, 8, 7. And the last number of the electronic configuration or in the electronic configuration simply shows the group to where an element belongs. So for instance, if there is a question that can ask about the actual group where element Q belongs to, we'll probably say group 7. Why? The group number of an element is determined by the number of electrons in its last or outermost shell. So it's either you can determine it from the number or you can count 1, 2, 3, 4, 5, 6, 7. And also another important thing is that we can be asked to relate or like bring out the actual number for the valence or the actual number for the period. So when you talk about the valence is the number of electrons an element can gain or lose in order to be stable. When an element has more than 4 electrons, it can only gain because it will need less electrons to be stable. So since we've got 2, 8, 7, it means this element Q, which is in group 7, has 7 electrons in its outermost shell. Now, for an element to be stable, it needs 8 maximum electrons in its last shell, which simply means it only needs 1 electron in order to be stable. Hence, the valence is 1. And the period is the number of shells. When you've got the diagram, you can just count 1, 2, 3. When you've got the numbers, you count the numbers present. So 1, 2, 3. So name element Q. Suppose this is in an exam when this was being written, it means this question was relatable to its reflection of ideas from the periodic table. Whereas to answer this, you probably need the periodic table. The first is that you identify it's in group 7. Then you go into group 7 and say, if this is element Q, you try to add 2 plus 8, 10, plus 7, 17. Then you look for an element which has got 17, that is beneath it or on as a bottom number, which means this is chlorine. The popular elements under bonding that are used from group 7 are mostly chlorine and fluorine. So name element Q, chlorine. How did I come up with chlorine? I'm saying I counted the number of electrons in each and every shell. I came up with the electronic configuration. And after I added all the electrons, I'm supposed to get the electronic number, or the number of electrons, or the atomic number. So which means the number of electrons was 17. I went to group 7 in order to look for the number that has got 17 beneath it. 2. State the period on the periodic table where element Q belongs to. Explain your answer. So we said the period number where an element belongs to is the number of shells. So how many shells do you have? 1, 2, 3. So I'm going to say period 3, and then we say, and this is because it has 3 shells. So we're going to say period 3, and this is because it has 3 shells. Lastly, explain how an atom of element Q acquires chemical stability. So this element that we have here, we said it is Q, and then 2, 8, 7. And the 7 I said is the last number, which gave us the actual understanding of the group number. Now that we're asking to say, explain how an atom of element Q acquires chemical stability. Chemical stability is more like how it can bond with others in order to be stable. By the way, bonding is the combination of 2 or more elements in order for them to acquire a stable structure. And for this instance, it means it has got 7 electrons in the last shell. Now, for it to be stable, it needs 8, which means this type of an element undergoes, that is a bonding, by gaining 1 extra electron. And this possibly is achieved through different types of bonding. Mostly, we can combine it with elements in group 1, where it can gain the extra electron it needs. Such type of bonding, which involves transfer, is called electrovalent or ionic. So explain how. So here, when explaining how, we're going to explain on the third one, we're going to say element Q gains So I'm going to say element Q gains 1 electron in order to be stable, or element Q undergoes bonding by gaining 1 electron in order to be stable. So these were the answers to the 2023 GCE exam on question 4, partially explaining the required concepts in the direction of helping you shape up and prepare adequately for an exam, and also helping you to build up on self-reliance, self-dependence. Do not forget to grab a paper and relate the same information. Tag others that may find this same video very much beneficial. This has been your tutor, Mr. Sensor from Sensor Academic Competitions. For now, till in the next video, it's a very goodbye. Stay focused.